There we go. So, PHS algebras, let's go. Don't freeze this time. So here's the scenario. You're going to be asked to work with every single form now. And for each one of these forms, so you'll see on this guy right here, right, there's going to be a vertex form, there's a general form one there, and you're being asked to find some of the following things. Domain, okay, range, okay, it says intercepts, we got to go through and do, and then extremes. We've got to write the extremes of each one of these, the increasing or decreasing parts of it, the positive and negative parts of it, and the axis of symmetry. Okay? So for each one of these things, you're going to have to find a specific part of it, and then based on which way the parabola is facing, whether it's facing up or it's facing down, that's going to change how I write out some of these guys here. Okay? And so we have to understand each one of those components. So the first thing I'm going to do and get out of the way is that unless otherwise specified, these parabolas go like, they look like this, right? Or they look like this. They're facing down or they're facing up. They're going basically, if you look at a parabola, it's either going infinitely in this direction, infinitely in this direction. So in terms of where does it exist left to right, like you can basically say for that guy is that it has no beginning, it has no end. It's literally from negative infinity to infinity, or you could just write out x is an element of real numbers. Both of those things indicate that this guy has no beginning and has no end. It's not really applicable to us right now, but it's still something we need to know that the domain does exist. All right, I'm going to try and pair some of these things together and see if I can make it make sense. I'm going to use a little bit of color here too. See if I can make this work. That, blue, yeah, there we go. So let's start out with our range and our extremes. This is probably the easiest part of it. So if I have to look for the range of something, okay, and I'm being asked to find the range of something, what it's basically saying is you need to find k and whether or not a is positive or negative. So you have to find k and whether a is positive or negative. How does that apply in reality? If I have one that looks like this, okay, and I have an hk of -2 and 4. So for a is positive, for a is positive, what I'm going to do now is say, well, my range for this guy, I always read from the bottom up. So a is positive looks like this guy here. That was my vertex. So then it's going to be from 4 to infinity. Okay? But I need to find k in order for that to work. Here's where this is going to become a little bit more complicated. What happens if I have, I'll just as an example here, what happens if I had something that looked like this here? What am I going to have to do if it's in factored form and I'm being asked for the range? I'm going to have to go to my memory aid, identify the formula that I need to use to find the actual value of k, and then I can write it out like this. But I would need to know what direction is it facing, and I would need to use this formula to identify what the k is so I could write it out like this. Okay? So that's where this guy becomes like rather complicated, is that you have to know all those formulas we learned the other day, and then you have to know how to apply them for each one of these individual guys right here. So what happens if a is negative? Okay? Well, what's the bottom of this function? It doesn't have a bottom, right? It's negative infinity, let's use the same number, -2 and 4, negative infinity to 4. Okay? The -2 doesn't matter in this case. I'm just putting that there as kind of like a placeholder. But that's what the range of this guy would be based on the direction it's facing, so whether A is positive or negative, and by what the value of K is. Questions on that? Okay. I'm going to try and put certain things together here, and I'm going to leave maybe this guy. Actually, I'm going to pair this guy with that guy right there. The range, the one that goes with this guy here, so I'm just going to do it next, is my extremes. And all extremes are max or min. And that's essentially it. So what that means is I just basically need to find out, same thing as this guy here, so I need K and whether A is positive or negative. Why does that matter in this case? Because if I have something like this, where A is positive, okay, then do I have a maximum? No. If A is positive, the maximum is going to equal dNE. Doesn't exist. Where A is positive, what's the minimum? K. That's all. What about A is negative? Well, in that case, my maximum is K, and my minimum is going to be dNE. Does not exist. So to clarify for Jesse and Connor, that's not a 0, that's not 1, it's dNE. Just to clarify for my handwriting there. Okay. It's not the best. I want to clarify. Lots of information happening here.
I was making fun of things, sir. Actually.
Appreciate that.
Nobody makes fun of people in this class, eh?
No. We create a very positive environment in here. There is no casual bullying at all.
We're all a big family.
Students to teachers or teachers to students. Yes.
It just goes right over your head.
Literally throwing it a short Alright, I'll take it. Alright, so we've done range, we've done extremes. Let's talk about increasing and decreasing next. So, for increasing and decreasing guys, okay, for this purpose right here, what is it that I need to find? So I need to find H and whether or not A is positive or negative. So the A being positive or negative is always going to matter with this stuff because it really impacts how I'm going to draw it out. So increasing or decreasing. If I have it in vertex form, this guy's really easy. But what would happen if I said find it, don't write this one down here. If I had that right there, and I said tell me what the increasing part of that function is, what would you have to do? Look to my formula sheet, know that it's asking for increasing, decreasing, know that that relates to H, so I'm going to plug this guy into H is equal to minus B over 2A, right? That's what I would have to do for that guy there. What would happen in this example if I was given the one I showed you last time, negative 2, x minus 3, x minus 7? I'm asking you to find out what the H is and the direction of A. Well, there's A, that's done, it's facing down. And the H for this form is Z1 divided by Z2, or Z1 plus Z2 divided by 2 is going to give me the H. Then I'd be able to go and write it out. For the vertex form, just as for simplicity's sake, negative 2x minus 4 squared plus 5, well, H is just going to be 4. I don't need to do anything fancy with it. I know that it's facing downward and H is 4, so I'll be able to figure this out using this handy dandy diagram. So, okay, let's just say, in this case, A is positive. Okay? If A is positive, this will here. So A is positive. Okay? And that is my axis of symmetry. Okay? I have an axis of symmetry that cuts this down right here. The axis of symmetry is basically H. And we're just going to look to start out for if I asked you, where is this guy increasing? So where is this guy increasing in this case? Well, it's increasing from whatever h is all the way to infinity. So now that I know that it's facing upward, now that I've found out what h is, I'd be able to write it out like that. Because it's starting at the h value and then climbing uphill and then going to infinity. Okay? And I'll do the same diagram right here. Below, a is positive. Okay? This is still my axis of symmetry. But what if I was asked for the decreasing part of it? Where is it going downhill? So then you're right, it's going to be, so decreasing is going to be negative infinity all the way to h. And the brackets are including for the h value both times, but excluding for the infinities. So, this is just like foundational stuff. Once I find h, no matter what the form, then I'm going to go to look at this on my memory aid, and then I'm going to go apply that knowledge. Okay? So let's keep working and say, okay, what about if a is negative? If a is negative. I still have an axis of symmetry, that doesn't change. Okay? So for an increasing part now, where is it walking uphill? That's the uphill part now. So for increasing on this guy, I'm going to have negative infinity to h. So it just changes because it's facing downward now. So just as to back up a bit, this is the answer. Like if you found h, it would be, and h was 3, it would be 3 infinity. You put these brackets down. That's you telling me the increasing part of that function. Okay? These questions here are asking you to go through and find all components of this for each one of those functions. For those that were here the other day when we were looking at word problems, pretty well word problems are only going to be asking for like one part of this. Okay? But this is just generally how we understand these functions. Okay? So facing down, again, axis of symmetry still exists. A is negative in this guy here, and I'm looking for the decreasing part of it. So where is it decreasing? It's decreasing from h to positive infinity. Nope. Gotta start moving this guy now. Move this guy over. So axis of symmetry is really easy. Okay, I'm just going to do it right here. Axis of symmetry. Okay, whether it's facing down, whether it's facing up, axis of symmetry is just going to be what h is, right? So whatever x value this line exists on, that's going to be the h value. Its other name is called the axis of symmetry. So when someone says, what is the axis of symmetry? They're saying, find h. Okay, go ahead and find h. So that's all that guy is there. Not overly complicated at all. Okay? So we've done axis of symmetry, increasing, decreasing, extremes, and range. Let's talk about positive and negative next, and then we'll get into the intercepts. So, where's all my code? So, making sure that's recording it. So, positive and negative. All right. When I go approach these guys here, what matters now is my A, whether it's positive or negative, and Z1 and Z2. Right? It includes all of those aspects. Okay? So then from here, what does that look like in practice? So let's just say, in this case here, A is positive. We're going to take some liberties and assume that all these questions like cross through the x-axis. x-axis. Okay? So if A is positive, and I have that as Z1 and that as Z2. Okay, let's think about if I was asked for, where does this guy exist when it is positive? It's basically everything above the line, right? Everything above the x-axis. So where will this exist? It'll exist from negative infinity to the first 0, union, second 0, all the way to infinity. Right? I think I'll do all 4 parts of this separately. You can see it. Everyone see the bottom of the board, Carter?
That's good enough. Don't worry about it.
Okay. So if I had this again, Z1, Z2, and I'm being asked to find the negative piece of where A, right? Of where A is positive. Okay? So where does this guy exist when it is negative? Well, that's pretty easy. It's literally just going to be from Z1 to Z2. That one is not overly complicated because it literally, where is it below the x-axis? From here to here. That's it. Right? So if you had zeros form, positive and negative is really easy to find. But if you're given something in vertex form, you're going to have to know on your memory aid, how to go back and solve for my zeros in that form so that I can then write this guy out here. So I would have to find these guys. If I'm in general form, right? Just as an example, that negative 2x squared plus 3x plus 5. If I was given that and being asked to find positive and negative, I would go to my memory aid and I would find that, oh yeah, I have to use that quadratic equation in this case, right? And then I'd be able to get my Z1, my Z2, and then depending upon A being negative or positive, that would dictate how my answer would look. So this is just an add-on to, once I find those parts, what do I do with it? How does it make sense? So then now, let's go facing downward. Still the x-axis, still Z1, still Z2. Okay? Where does this guy exist when it's positive? Okay? That's pretty easy. So this is A is negative. Where does he exist when he's positive? From Z1 to Z2. And that's it. Okay? Same thing, facing downward. Okay? X-axis. Z1, Z2. Okay? And I'm looking for just the decreasing pieces. So A is negative for this guy. Where is it decreasing? Well, this is one of those longer ones. Starting at negative infinity, going to the first 0, union, starting up at the second 0, going to positive infinity. So that would be my positive and negative parts. Okay? So, questions on that? No? Alright. So, from there, we've done positive and negative. Let's talk about intercepts for a second. And this guy's really rather tough. And I'm going to need another table here. To use my tool, but I don't trust it. Not to reach the board. Bring you closer. Don't unplug, don't unplug, don't unplug, don't unplug, don't unplug. Okay. So let's continue talking about our intercepts. Okay. So what the heck are intercepts? Well, the x-intercepts we can write down are basically also known as zeros. So z1 and z2. That's my x-intercept. What do I know about the x-intercept? I know that y is equal to 0 for that guy there. That's basically it. So if I'm asked to find the intercepts, I need to find both the x-intercept and the y-intercept. And what do I know about him? I know that he exists when x is 0. Okay? That one's easier to solve for. Okay? Because, like, for example, if I was given something that looked like this guy here, so if I was given something that looked like this guy here, negative 2, x minus 3, x minus 7, in order to find the y-intercept, what am I doing? I'm literally just plugging in x is 0. So it would be y is equal to negative 2, 0 minus 3, 0 minus 7. And then you would just multiply it, right? Like do the brackets, solve. Y is equal to negative 2, negative 3, negative 7. Y is equal to negative 2 times positive 21. So y would be equal to negative 42. That would be the y-intercept. But I want to be clear here that that's not just the answer right there. It would be x is 0 and y is negative 42.
So is it y1, m, what's that line above it mean? I don't understand your writing when it's like
Y-intercept?
Y-intercept?
Like, seriously, is that what your writing's supposed to mean?
Yeah. That's supposed to be y-intercept.
Sir, it looked like y.
I know, okay, moving on. So that would be if I had it in factored form. Okay? Now, let's do an easier one really quickly here. What if I was given one in general form? Okay? What do we know about y-intercept? We know that x is 0. Do we even have to do math on this one? What's the y-intercept of this guy?
5.
5. Right? Because 0 squared is still going to be 0. 0 times this will make it 0. 0 times this will make it 0. So your c, that's the only thing really valuable from that guy. The a tells you which way it's facing. The last number tells you what the y-intercept is. So it does have some value. Okay? So we have all of that. So this is factored form. This is general form. Yep.
So the 0 and the negative 42 are your zeros?
So, okay, good question. So zeros are known as my x-intercept, so z1 and z2. The y-intercept, so intercept just means where it crosses the axis. And I will agree that it's super confusing that when they call something zeros, they're specifically talking about x values. That's kind of weird because it's not like he doesn't have 0. It's right there. So why isn't he called a 0? Kind of weird. It's just that the phrasing of all of this is such that when they say zeros, they mean plural. We're dealing with parabolas. Zeros, the only one that has multiple is x values.
Okay. And then that negative 2, the negative 3, and the negative 7 in the example were just kind of made up?
I'm just making this up as if I was given it in factored form, I would just plug in x is 0 and then just solve for it. So I didn't do it here, and I should. It's not just y-intercept is equal to 5. It's also a point. Okay? So it's also 0 and 5. So then last but not least, what if I was given something like x minus 4 squared minus 64. And y is equal to. Okay. So if I was given this guy here, okay, then I would still plug in x is 0. Y is equal to 2. This guy is going to be a 0, minus 4 squared, minus 64. We're literally just algebraing it out. Sorry for that. Okay, so this would become 2, that would become 16 minus 64. That would become 32 minus 64, so y would be equal to negative 32. The y-intercept would be 0 and negative 32. Okay? So this is strictly just y-intercept stuff. Okay? And I should have given myself more room for the x-intercept stuff. Good job. Dang it. Okay. So, because I think, oh yeah, got to the end. Screwed up. So, let's go talk about these guys here for a second and how that might work. I'm going to just take a quick photo of that because I'm probably just going to erase those guys there. I'm going to need that room. I'm fine. Here we go. So I'll post that on as well. Let's talk about the x-intercepts and how that guy comes into play. So I'll get rid of this for now. Okay. I'll rewrite examples like that later next to it. So y is equal to 0. Okay, this is the tough one. The intercepts basically mean finding the zeros. So if I was given something in my zeros form, so y is equal to that one I just had, negative 2, x minus 3, x minus 7. That one's really easy, okay? If I need to find my intercepts, my x-intercepts, z1 is positive 3, z2 is positive 7, done. That's as much work as that's going to take, okay? Because it's zeros form, so it's giving me the zeros. Really easy stuff. Okay? Now, what would happen in an instance, however, when I was given, so negative 2, x minus 4 squared minus 64, and I'll make that a positive 2. Okay? Actually, I'll make that, what can I make that? What can I make that? I'm going to rate this guy by 2 square root of 1.5. Okay. I'm going to have like that. So if I was given something in my vertex form, there's 2 formulas for it, right? And there's 2 approaches to it. It's either I am going to just set y is equal to 0 and algebra it out. Okay? Or I'm going to use a formula. And I'm going to show you that formula here in a second. So, use this in the same color. 0 is equal to 2. So, I'm looking to solve for x. If I'm ever working my way into an x value, this is not just true of this year, this is true of like every year that we're working on here. And I'm sorry, when you see it next year as well, whenever we're solving for an x, like we work our way in towards it. When I solve for a y, it's usually pretty straightforward when I have the function. Okay? So start by getting that k out of the way. That's I suggest that all the time. So 72 is equal to 2x minus 4 squared. Okay? I would then divide by 2. Divide by 2. We would now have x minus 4 squared is equal to 36. Okay? We could then square root both sides, and then I would be left with, so I'll just do this up here. Okay. 6 is equal to x minus 4. But it's not just a 6. Okay? It's not just a 6 in this case, and I want to be clear about that because let's just take a step back for a second and think about right now. Mr. Mack,
Yes, sir.
if I said square root of 36 right now,
Yeah.
okay? What are the possible ways, using the same number, like the square, or the root of it, what are the 2 possible ways I can get 36?
You mean square root of 4 times square root of 9?
Not that, so that like the root of 36, there's 2 ways to make it, using like the root of it. So like if I'm taking the square root of that guy, right? Like what I'm trying to say is, so if I did 6 times 6 is 36, that's
Or
easy.
negative 6 times negative 6.
There we go. The other option is negative 6 times negative 6 would give me positive 36. These guys are parabolas. They have 2 answers. We're not necessarily sure in this case, when we took the square root of that, how that guy was made. Was he made with positive 6s? Was he made with negative 6s? Okay, so if that's the case, this becomes plus minus 6, and then now I split things off. So I'm going to have 6 is equal to x minus 4 as one option. And I'm going to have negative 6 is equal to x minus 4 as an option. And then I would just solve for x. So in this case here, I would have 10. In this case here, I would have negative 2. So my z1 would be negative 2. Doesn't really matter what I label it as. My z2 is going to be 10. So I could write negative 2 and 0, and 10 and 0. Okay? So this is essentially how I would go about for my vertex form. That's what we would have to go through to get our zeros. If you go back to the example here, or this one here is just asking for intercepts, so I don't have to do any of this weird set notation, interval notation stuff. Okay? I don't need to do any of that. I'm just asked for what are the intercepts of this guy here. So this was just strictly working with vertex form. The other option for this guy here, if you want to work on it, let's go with this guy here. So if you hate being an algebra, okay, and you say algeno, option. So we'll say this is option 1. I apologize. Okay.
No.
It's basically h plus or minus square root of negative k over a. So it kind of just does this work for you. And it's if you can see it and you remember the rules with the actual value of h, you can literally just plug in. So it would be 4 plus or minus square root of negative 72 divided by 2. And then that would give me my answer. Some people prefer this guy here. I still want you to have your abilities to do this because it's transferable to next year. Sorry.
Is Z1 B10 or does it have to be that way?
Pardon?
Can the Z1 and Z2 be flipped around?
Yeah. I mean, I prefer putting, like, if we read things domain-wise, we like to read it left to right. That's more of a preference thing. Like, you would not be wrong if you flipped them. If I wrote it as Z1 was 10 and Z2 was negative 2, there wouldn't be wrong. So it's literally more of a preference thing. My brain likes to see things go from left to right because that's how it works, like with the domain and such. So just applicable nature, like I would put the first guy I would encounter coming from the left because intercepts, it doesn't matter, it's just a value. But for positive and negative, the Z1 and Z2 like kind of matter. Like I would label the first guy I interact with Z1, the second one Z2, so then that would matter here. Because if you wrote negative infinity 10 and then, negative infinity to 10 and then negative 2 to infinity, you'd be wrong. So like in terms of writing out the rule, is it wrong? Writing it out that way, is it wrong? No, but it would matter here in terms of writing the positive and negative. That's a good question.
Do you mean encounter on the x-axis or encounter when you do your math?
This here?
No, the one that Brooklyn's talking about with the 10 and
These
the
two?
negative.
Yeah.
How do you know which one is you encounter for?
Oh, so when I read things, I talk about when I'm talking about things in positive and negative and increasing and decreasing, I'm talking about it as if I'm talking with the domain of it. And the domain always reads left to right. So in terms of when I say it's the first guy I encounter, he's facing up and it's -2 and 0 and 10 and 0. He'd be the first guy I encounter
Okay.
as I go across. So it just matters. It matters when I'm talking about positive and negative pieces.
Yeah.
If I'm just solving for intercepts, let's think about this in context. If you're looking at a real situation here, and let's just say, for example, we had that same function you're talking about. Okay? And it looks like that right there. That's -2, and that's 10 right there. And the question's basically just saying that there was, there's a submarine and it shoots a missile at a boat on the surface. The trajectory of that missile follows a parabolic arc. Okay? Where does it run into the actual ship? Well, in context, if this guy here is like time or distance, let's just say, I could never have a negative time or a negative distance, so I would know my answer would be the second 0, it would be 10, because that exists in the real world. So then that's where it comes into play as well, where it's like my logical, analytical part of my brain is going to have to identify that's the guy that I'm solving for the second 0 in this case.
It's like something can't travel at like negative speed.
Yeah. So you're always exactly. So there's logic that's going to dictate where you go with it. This guy here, in terms of solving it, I find this one easier. I just want you to have that skill set for next year and for solving for x. So it'd be square root of 36. Same thing applies, right? 4 plus or minus 6 is going to give me my two answers. 4 plus 6 is 10. 4 minus 6 is -2. That's the other method that I would use. If you prefer formulas and you want to just plug things in, you can go about it and do it that way right there. Okay? So, last but not least, what if I was given something in let's trying to think of something that would be factorable here that would actually work in this case. X plus, okay. Now whatever. Just trying to think of a good example for what would add together to get, or
Who sells that cheap?
multiply together to get 10, but then add together to get 7. Okay, I guess it's the same thing, that's what it is. Okay, or we could even go, so on this guy here, if I was given something, I just want to have the numbers to be kind of pretty. This should technically work out okay. No, that wouldn't work. Anyway, so regardless of the function given, if I'm given something and it's in general form, okay, I'm going to have to know now that this is the formula that I'm going to want to use. Okay, so that's A, that's B, and then that's C. So if I'm saying find the x-intercepts of this guy here, we're literally just going to plug things into this guy here. Okay, so 7 squared minus 4 times -2 times 5, and then 2 times -2. Okay, so on this guy here, I've done a couple of examples like this, but I'll work through it in full now. -7 plus or minus square root of 49 minus 8, 5. So what did I do wrong there? What's going to end up happening to this guy here?
Not to be able to solve it.
Well, this one does work, but it's subtracting, and because 4 times -2 times 5 is going to be a negative, technically this becomes an addition statement now, right? So then, now when I approach this guy, okay, I would go ahead and say, so all of that over -4, so -7 plus or minus square root of 89, so that's going to be rather ugly. Oh, if I just left it too positive, this would have worked a lot better. It's done. So square root of 89, all divided by -4 in this case. So on these guys here, unless it specifically asks for it, feel free to write in as decimals. So like, what is the square root of 89? What is the square root of 89?
9.43.
Okay, so 9.4. So we would say -7 plus or minus 9.4 divided by -4, and then you split it off into both sides. For those that haven't looked at quadratic equations in a while, okay, you're going to have one side -7 minus 9.4 divided by -4, and -7 plus 9.4 divided by -4. And then we would just solve for those guys. Jesse?
Yeah.
Pay attention, buddy. The reason why you don't know what's being written on the board is because you're not paying attention when I'm telling you what it is.
Fair enough, said I didn't know. Do that.
So divided by 4, -4. So this would be negative value. This would be positive 4.1. And then 2.4 divided by -4 is 0.6. So the zeros for this guy would be 0.6 in 0 and 4.1 in 0. Okay? Those would be my two answers for that, or potential solutions for this guy right here, because I go through it. So if they ask for intercepts, they're asking for both the x-intercepts and the y-intercepts. It's a rather challenging concept. You have to be able to know how to make sense of all of these things in front of you here. Okay, and I'm going to take a photo of this guy here minus, and I'll include the photo of the y-intercept stuff, and put that on with this video. But yeah, now you can go ahead and approach the actual questions on that next page there, where it starts to talk about, you have vertex form. Where is it here? So go ahead and get to it, x plus 1 squared minus 9, and then x squared plus 2x minus 8.